this to exponential form. So what I'm going to do is I'm going to take my base, which is 2. Remember, when you convert from log to exponential, this is your base, this is your exponent, so it's 2 to the third, and this is your argument, or your answer, or your value, 3x plus 9. If I do 2 to the third power, I'm going to get 8. So I have 8 equals 3x plus 9. My next step would be to move the 9 over. I'm going to subtract it over here. So I get negative 1 equals 3x. And then my last step would be to divide both sides by 3. So x actually equals negative 1/3. And you're done. Again, I converted base to exponent equals argument. 2 to the third equals 3x plus 9. Then I just solve for x. So let's look at b. b, my base is 5. So I have 5 squared equals 4x minus 15. 5 squared is 25. So I have 25 equals 4x minus 15. I'm going to add the 15 and move it over with the 25. So I'm going to get 40 equals 4x. And then for my last step, I'm going to divide both sides by 4. So x equals 10. That's the answer to B. And again, if you want to check these, just plug them in to the equation and see if you get the right answer. For example, 10. 4 times 10 is 40. If I were to plug in 10, 40 minus 15 is 25. So log base 5 of 25 equals 2. That's true because 5 squared equals 25. So you can check your answers. So let's look at the last one. I don't have a base here. So what does that mean? Well, when there's no base there, you assume the base is 10. Whenever there's not a base written for logarithm, for a common logarithms, the base is 10. Remember, natural logarithms, the base is e. So this is basically 10 to the first equals, so 10 to the first equals my argument, which is x. Well, this one's pretty simple. What's 10 to the first power? 10. And 10 equals x, so the answer is 10. And that's how you solve equations, by using logarithmic form. Now, I'm going from logarithmic to exponential. Now let's look at number 22 on the review. That was number 21. Let's look at number 22. So I'm going to start with number 22. Number 22 is a little bit different. So I've got 22a. 22a says 4 to the x plus 2 equals 20. Now, normally I would look at this equation and I would say, hey, this might be one where I need to find common bases. But the problem is you don't have common bases. 20 cannot be put in a format where it's a power of 2. 4 can, and 4 can be a power of 4. 20 cannot be a power of 4, and it cannot be a power of 2. You cannot have 2 to some power give you 20, or 4 to some power give you 20. It's not going to work. So our option on these is to take the logarithm, remember, of both sides. So I'm going to take the common log of both sides. So I'm going to take the log of this side, and I'm going to take the log of this side. Take the log of both sides. When you can't find common bases, take the log of both sides. If you remember the properties of logarithms, remember whatever the exponent is of your argument can come in front. So I can have x plus 2 in the front times log of 4 equals log of 20. And then I'm going to divide both sides by log of 4. So that leaves me with x plus 2 on this side. And I've got log of 20 over log of 4. Log of 20 over log of 4. And I don't have my calculator with me, so whatever you get for this value right here comes down here. And then once you find this value, Then you subtract 2 to find your x.